pressure regulator.
Okay.
That's going to set your set point for your differential between the high side and the low side. This is the needle valve that sets the speed which water can flow into the valve to close it. And that's you. So in is slower, out is faster. This is the high pressure side port, the low pressure side port. So this, when high pressure comes in, this pressure regulator will allow water to push the diaphragm down and throttle the water going across this valve. This is the outlet to the low pressure side. It can only work off a differential. So the more differential you have, the faster it'll work, which is what this needle slows down. So as you get closer to the bottom, it tends to travel faster based upon this pressure setting. If you close this valve, it should stop the valve where it's at. If you continue to see the valve lift up, it means the diaphragm is torn or punctured.
Through the sight glass at the top there, in that, what do you call that?
This is the position indicator stem.
Okay.
It's directly tied to the top of the bonnet.
Okay.
So as that valve travels up and down, this position indicator tells you that.
Okay.
So you can
gives
view
you
it.
position. Yeah.
Gives you position.
But if that's not functioning properly, either the ports are clogged, the regulator is jacked, or you've got a torn diaphragm. But if you have a torn diaphragm, then the valve would be open all the way, more than likely.
It does tend to go that direction, but not always. Sometimes you can get a pinhole, and the amount of flow from the high pressure side on top of the valve will keep it sort of working, but not all the way, because the top of the valve is a larger diameter than the bottom, which is how you get that hydraulic advantage of using the high pressure to shove that valve down. There's a spring in here, typically, that's used that if everything goes off, the spring, if there's equal pressure to both sides, this valve will get pushed down.
But then incoming line pressure, if it's high enough, it'll lift the disc.
So the incoming pressure on the high side will lift that spring as long as this pressure regulator defeats it. So the way it works is high pressure comes in, it goes to the top of the valve, and this pressure regulator is actually a relief.
Okay.
So you set the pressure you want downstream based upon this. So this allows liquid on the top to get past.
Okay. But it's just not enough flow to cause a problem downstream. It's not going to build enough volume to defeat or be a problem down the line. So.
Correct.
Okay.
Yeah, so this has a flow direction on it. So it's going from high side to low side, and that's what allows this to lift.
Okay.
So the high pressure, when this closes, will close down.
Gotcha. Well, I kind of got you, but I get what you're saying. So there's multiple steps in there, and we need to set our settings on each one. But you said earlier that more so flow than pressure is what we're adjusting, right? The volume.
So as lineups need to be brought on and off, it's based upon flow. So this PRV has a coefficient of friction, right? So it'll only let so much water through before it defeats that pressure, and it just keeps rising and rising and rising. Same thing with the low flow, is it can only pinch down so much before you're out of range on your pressure regulator. It's just not going to regulate anymore with this pressure regulator.
So when you say not regulated anymore, it's just going to go wide open and it'll flow the line.
Basically, there won't be enough pressure to have a differential.
Okay.
The valve will just stay either open or kind of closed, but the force of the water tends to always open them all the way up.
Okay.
And if there's no differential, you don't have the hydraulic advantage to control it.
I got you.
So
I kind of got you.
The low flow, high flow comes into play along with the pressure. It's the triangle balance game. If you adjust for pressure, you can lose based upon your flow. If you adjust on flow, you may lose pressure. So you have to kind of do that together.
So that's why when we choke it down, of course, I think we realize that when we choke it down to get the system to completely calm down, that we can lose enough volume so we don't have the heat transfer at the heat exchanger, because we just don't have enough flow to carry back the heat, because there's just not enough flow.
Correct.
But yet it's acting pretty, but not doing its job.
Right. You're augmenting what the header does based upon that last valve. instead of allowing the PRVs to do it and bring on stages and take off stages as needed based upon flow once you get your pressure set, and that has to kind of jive together.
So that's why the solenoid valves on the last one going out and being electronic, tied to the computer, would be how they in the past efficiently staged up or down based on flow demand by what it saw in the computer, whatever that program algorithm or
Absolutely.
was.
So
Okay.
what you would do is, based upon your flow through the plant, is you would have gallons per minute thresholds of, say, if you're running 1,200 gallons per minute, you need to have 2 headers online or 3 headers, and the pressures would still do the same thing, but it would
The volume.
the volume between the 3 headers.
Okay.
Because if you tried to run that through all of one, you would have no control. It would overpressure one lineup, and your pressures would go too high, and it wouldn't because the settings are wrong. Is you can't force that much water through the setup because of the friction coefficients of going through that piping.
So yeah, so you can get the pressure, but you just won't get the flow.
Correct.
And okay, all right. Well, I think that's a good starting point for our conversation. Thanks, Jason.
Yeah.